In the last video we practiced those mole-to-mole ratios so we can convert between moles of our items in a balanced equation. But when we're in an actual chemistry lab, or even scientists who do this for a living day to day, we don't have a balance that can measure moles, and so for the majority of times, we're going to have to be converting our moles to grams so that we know how many grams of product that we're going to get, or we know how many grams of our reactants to weigh out to add together to get our product. So grams is going to be more useful in most cases just in a practical day-to-day purpose in a lab situation. So we're going to be again using the equation on how to form ammonia and some rules on how to convert to mass calculations. Alright, first of all, we want to change the grams of our original item into moles using the molar mass. So if they give us our, let's say they give us moles of nitrogen, and we want, they give us grams of nitrogen, and we want to know how much. We want to know how many grams of ammonia we can produce. Well, we're going to want to take our grams of nitrogen and convert it to moles, and we know how to do that with the molar mass from the periodic table. Now once we're at moles of nitrogen, we can convert using a mole-to-mole ratio. We can convert to our second substance. So if we wanted to again have the mass of ammonia, then we would want to go from nitrogen to ammonia with a mole-to-mole ratio. And that now we have the moles of our second substance, but we want the mass of ammonia. So we will have to do another molar mass from our periodic table to convert moles into grams. We want to make sure to include units with our substances. We don't want to just put moles and grams. When we just use grams and moles without labeling what what substance we have, sometimes it's very confusing as to where we're at in the problem. So you need to make sure that you are using the units, grams and moles, whatever it might be, and that you are also telling me grams of what. So is it grams of N2, grams of H2, grams of NH3? You need to make sure that you're including two things with each of your units. And you're going to continue to use the molar mass and your mole-to-mole ratios until you get to your desired unit. And if you're following those three steps, the three rules on the previous slide, then it won't be too many steps. You'll get this done fairly easily. So let's do a practice problem, and I'm going to rewrite our equation on here. It's the same one that we've been using in several videos now. And we want to convert the number of grams of ammonia that can be produced when we react 5.40 grams of hydrogen with an excess of nitrogen. Now that excess of nitrogen really doesn't come into play quite yet. It will in a future video as we get into limiting and excess reagents. But right now you know that you have plenty of nitrogen here to react with the hydrogen, so you're not going to run out of something. Like if you were trying to make your 5 dozen cookies and you needed those 10 eggs but you only had 6, well then you don't get to make 5 dozen cookies because you don't have enough ingredients. So we don't have to worry about this here. We have an excess of nitrogen. So we want to convert our 5.4 grams of hydrogen into grams of NH3. So we want to start first of all with a balanced equation, which we do have, and then we want to start setting up our problem. So I have grams of H2. Notice I'm not just putting grams, but I'm also labeling what substance I have the grams of. And we want to get rid of grams of hydrogen, so I'm going to put that on the bottom. And the only thing that grams of hydrogen can go to is moles. That is the only item that grams can go to. Grams can go to moles of hydrogen. We can't switch to moles of NH3. We can only go from the one substance to the other substance. I'm going to go through and fill out all these numbers in a little bit. I'm going to start off just by setting up my problem with all of my units to make sure they cancel. So my grams of hydrogen are going to cancel. Now I don't want moles of H2, so I'm going to get rid of that by putting it on the bottom of my next conversion. And this is where you can convert to your other unit. So moles of hydrogen could go to grams of hydrogen, but I was just there. It could go to molecules, it could go to liters, but I don't want any of those. I want to switch to another unit, in this case NH3, ammonia. And so I need to do a mole to mole ratio, and I want to convert the moles of hydrogen to the moles of ammonia. And before we would have stopped there, but this problem is asking us for grams of ammonia, not moles. And so once I have moles of ammonia, I can get my grams, by doing a molar mass. So if I put moles of ammonia on the bottom so that they'll cancel, and I can cancel out my moles of hydrogen from earlier. The moles of ammonia can go to grams of ammonia, and it could have went to molecules, it could have went to liters, it could have went to anything, but I specifically wanted grams, and so I want to go to grams here. Now I want to go through, I've canceled all of my units, the only thing that's left is the unit that I want at the end. And so now I need to go through and figure out what numbers go in all of these blanks. Well, moles and grams is a molar mass, and so for hydrogen the molar mass is 2 times its mass of 1.0. So my molar mass for every 1 mole of H2, I have 2.0 grams of H2. Mole to mole ratio, we get those from our coefficients in a balanced chemical reaction, and so H2 has 3 moles and NH3 in our balanced equation has 2 moles. And then here I have another grams and moles, only this time my molar mass is for NH3. So for NH3 I have 1 nitrogen with a mass of 14.0. And for hydrogen I have 3 of those, and each is 1.0. So my total molar mass, if I were to add everything up and make sure that I'm doing all of my significant digits and things, I get 17.0 grams for every 1 mole. And now I have everything set up, so calculator wise I'm going to take 5.40 and divide it by 2, and then personally when I'm doing this, this is what I would do. 5.40 divided by 2, and then I hit equals, and then I multiply it by 2 equals, divide it by 3 equals, and then I multiply it by by 17.0. If you wanted, you could multiply all the top numbers and then divide it by the bottom numbers. There's multiple ways of going about calculating this, but you should get the answer of, and I didn't finish this one on my sheet, so I am backpedaling to try and find it really quick. I should get, 31 grams of NH3. So 31, and I'm only allowed 2 significant digits because of the 2.0 from my hydrogen. So 30.6 is what you would get calculator wise, so that would round up to 31 grams of NH3. So sorry for the stalling right there, but so you try it several different ways, but make sure that you get 31, and if not, then we need to talk about calculator. Alright, let's move on to problem number 2. And in this case, we always want to make sure we're starting with a balanced equation, which we are. And we want how many grams of acetylene? Acetylene is this C2H2. We want to know the grams of that when we start with 5 grams of calcium carbide. So we have 5.00 grams of CaC2, and we're going to convert that into grams of acetylene. Alright, grams of CaC2 is going to have to go on the bottom to cancel those out, and moles, because grams can only go to moles, that's the only conversion that we know. and grams are going to cancel. Now I don't want moles of the calcium carbide, and here's where I can do my mole to mole ratio. I can get away from that substance, and now I can get into my acetylene, C2H2, which gets me a little bit closer to grams of acetylene when I can have moles, and your moles of the calcium carbide were canceling there. And lastly, I can convert the moles of acetylene into grams of acetylene, and I'll have to do that with a molar mass, which I'll do here in a second. So I've got all my units done and canceled, and now I need to go through and I need to make sure that I have the molar masses and numbers, all of that put in correctly. So for the CaC2, I have 1 calcium, and its molar mass is 40.1, and I have 2 carbons, and they are 12.0. So if I add my molar mass up for calcium carbide, I'm at 64.1. So that's my mass, and that's always for 1 mole. My mole to mole ratio I get from my coefficients in my balanced equation. I have 1 calcium carbide and 1 acetylene. So multiply and divide by 1, it's not going to affect our problem in this case. Now for C2H2, I have 2 carbons at 12.0 each and 2 hydrogens at 1.0 each, so 24.0 and 2.0. And this is for people who just need that little bit of review on how do I get a molar mass. So my molar mass is 26.0, and that is per mole. And now I can calculate. Now I can go through and I take 5.00, divide it by 64.1, and multiply it by 26.0. I'm only allowed 3 significant digits, and so your mass of acetylene should be 2.03 grams of acetylene, C2H2. So there is my amount there. Alright, last one. I want how many moles of CaC2 are needed to react with the 49.0 grams of water. Now this is the same equation as on the previous slide. I'm not going to rewrite it just for time and space. So 49.0 grams of water, and whenever I have grams, I know I can go to moles. Make sure that you are putting not only the unit but also what substance it goes with it. So grams of water, moles of water. Make sure you're doing that, please. And once I have my grams canceled, and I can cancel out my moles of water by doing a mole to mole ratio. So I need to get from water to calcium carbide, and I can only do that through a mole to mole ratio. That's the only way to go from one to another. And I can stop there. This is asking me for how many moles I need. I don't need to convert it to grams. And so I think with that I'm going to stop and let you fill in the molar mass and let you fill in the mole to mole ratio. Your moles of water will cancel, and then all you're left to do is do the multiply and divide that you need to do to get your answer, and I'll finish checking that in class, so do make sure that you finish that one up and come prepared for class.